Hello friends, my name is Prarthana Tibile. I am a student of 3rd year B.Pharmacy from Shivajirao Jondhle College of Pharmacy, Asanga. Today I am going to explain a topic from subject Industrial Pharmacy 1, that is formulation and manufacturing of aerosols, under a guidance of Geeta N. Mohire ma'am, which is assistant professor of our college. Formulation of aerosols. It contains two essential components, that is product concentrate and another one is propellant. Then what is a product concentrate? Product concentrate contains active ingredient and other necessary agents such as solvent, antioxidant and surfactant. Propellant. Single or blend of various propellant is used. Blend of solvent is used to achieve desired solubility characteristics. Now let's see about the type of aerosol system. Aerosol system. There are four types of aerosol system. First one is a solution system, also called as two-phase system. Second one is a water-based system, also called as three-phase system. Third one is a suspension or dispersion system. Fourth one is a foam system. In foam system, there are four types: aqua-stable foam, non-aqua-stable foam, quick breaking foam, and thermal foam. Let's understand about each and every type of aerosol system. Two-phase system. It contains both vapor and liquid. Drug is soluble in propellant, hence co-solvent is not used in it. Propellant well is used as single or mixture form. In mixture propellant with vapor pressure less than propellant well. Vapor pressure reduction. Bigger size aerosol particle. Here some example of propellant which are used: propellant 12 by 11 and propellant 12 by 114. Here the general formula of two-phase system, which we use active ingredient and propellant, and another one is formula for treatment of asthma. In this, isoprotenolol HCl, ascorbic acid, ethanol and propellant is used. Three-phase system. So let's understand about three-phase system. It contains water phase, vapor and propellant. Water is immiscible with propellant. To increase solubility, co-solvent and surfactant is added. Co-solvent is ethanol and surfactants such as non-polar esters of oleic acid, palmitic acid and stearic acid. Suspension system. In suspension system, we use suspending agent. It generally used as oral inhalation aerosol. Active ingredients is dispersed in propellant or mixture. Physical stability is increased by control of moisture content. Active ingredient with minimum solubility. Initial particle size should be less than 5 micron. Propellant density and suspending agent. Now let's understand about foam system. It contains of aqueous and non-aqueous vehicle, propellant and surfactant, and it have four types. First one is aqueous stable foam, non-aqueous stable foam, quick stable foam and thermal foam. In aqueous stable foam, we use propellant 3 to 4%. Dry spray is produced. Propellant is interior phase. Steroid antibiotics. In non-aqueous stable form, we use emulsifying agent, that is glycol. In quick breaking form, we use propellant, that is external phase. Cationic, ionic and non-ionic surfactant are used. It also used for a topical application. Thermal form. It delivers as foam on application of heat. It prepare for shaving cream. Manufacturing of pharmaceutical aerosols. There are three types of apparatus used in the manufacturing of pharmaceutical aerosol. First is cold filling apparatus, second is pressure filling apparatus, and third is compressed gas filling apparatus. Now we will study the cold filling apparatus. This is the apparatus of cold filling. Cold filling apparatus is a simple apparatus which comprises of an insulated box fitted with coil copper tubing to increase the area exposed to cooling. This system can be used with both meter and non-meter valves. Hydrocarbon aerosols cannot be filled using this system, since an excessive amount of propellant escape and vaporizes from it, that may form a explosive mixture at the floor level. However, a fluorocarbon vaporizes or vapors fluorocarbons vapors are heavier than air and thus do not form explosive or flammable mixture. There are two methods involved in cool filling apparatus. In the method A, the product concentrate are chilled to temperature of -30 to -40 degree Fahrenheit. The chilled product or concentrates are added to the chill aerosol container. The chill propellant is added through an inlet valve present under the side of the walls of the aerosol container. In the method B, both the product concentrate and the propellant are chilled to -30 to -40 degree Fahrenheit. Then the mixture is added to the chill container. In the both above method, after the aerosol container are filled, the valves are set in its place and filled aerosol container are passed through a water bath in which the contents of the container are heated to 130 Fahrenheit to test for the leak and stain. Then the containers are dried and capped and labeled. Advantages of cold filling apparatus: easy to process. Disadvantages of cold filling apparatus: aqueous product emulsion cannot be filled. For non-aqueous system, moisture are appear in final product. Then the second apparatus is pressure filling apparatus. In pressure filling apparatus consists of metering burette capable of measuring the amount of propellant to be filled to the aerosol container. The propellant is added through the inlet valves present to the bottom of the valves under its own vapor pressure. A cylinder of nitrogen or compressed gas is attached to the top of the valve, and the pressure of nitrogen causes the propellant to flow to the container through the metering burette. The propellant flows to the container stop when the pressure of the flowing propellant become equal to the pressure of the container. Method: product concentrate is filled through the burette room temperature. Propellant is added through the inlet valve. Flow of propellant stops when pressure of filling propellant becomes equal to the pressure within the container. Advantages of pressure filling apparatus: prefer for solution, emulsion and suspension. Less contamination is occurred. Less propellant is lost. Third one is compressed gas filling apparatus. Propellant used in this apparatus is compressed gas. Pressure reduced by pressure reducing valves. Pressure use 150 psig in this apparatus. Method: product concentrate placed in container. Valve slim in its place. Air evacuated by vacuum pump. Filling head inserted into valve opening. Valve depressed and gas allowed to flow into container. Gas shaken during and after the filling by mechanical shaker. Here we complete the topic formulation and manufacturing of aerosol. I hope you like this video. Thank you.